Happy Monday, everybody, and happy 2021. We did it. We survived. We made it to the new year, and I don't know about you, but it's completely different. As soon as that ball dropped, life just totally different. Everything's changed. All the worries from 2020 are totally gone. So we're just going to not even think about those. But we are continuing with our live streams, of course. So we're so happy that you all are joining us for this new year, new stream. And we're going to keep this train rolling. We're going to keep doing these streams through this year. I've got a bunch of fun topics planned. By the way, my name is Patrick Hess. I'm the Planetarium Specialist at Union Station. And if you're tuning in for the first time, welcome. We are live streaming live here from our virtual studio in Kansas City. And we have been live streaming for the past, oh my gosh, almost 10 months now. Started in March of last year. And if you're a returning watcher, then welcome back. I know we've got some of our longtime watchers in the comment section. And as a reminder, this is a live stream, unlike whatever the other alternatives would be. So if you have anything to say, be sure to chime into the comment section. We love hearing you guys say hello. Let us know where you're watching from. That's always fun. And of course, if you have any questions or comments, then please put them in the comment section. And this should be a good one because there may be a controversial topic that we cover today. As a reminder, this is a live stream put on by the Arvin Gottlieb Planetarium at Union Station. And Union Station, Kansas City, is open to the public. And if you want to come see one of our live shows, we definitely encourage you to do that. It's a great way to support us as well. Just a little production note here, though, that Union Station is still open to the public, but Science City and the Planetarium will be closed until Thursday the 14th, and we close every year in January for standard maintenance and training, so that's nothing out of the ordinary, but just to let you know that we are technically closed to the public right now, but we will reopen next week for all of our shows. We've got Eric in the comments already saying hello, or howdy from Lenexa, break a leg. Also, Granny from Richmond saying hello, so hello Granny, thanks for watching. So everybody, be sure to shout out in the comments. And we're going to dive right into our topic today. Normally I go over some space news, but we did a ton of news last week because last week we did a roundup of all the exciting space news that happened in 2020. By the way, as a sidebar, all of our previous live streams can be found on our YouTube channel. Just search for Arvin Gottlieb Planetarium on YouTube and you can find us there. So if you missed any of our previous live streams, we've covered a ton of fun topics, and I'll try to point you to some of those throughout the stream. But we're going to skip the space news this week and dive right into our deep dive topic today, which is Pluto. Pluto is the final stop on our solar system tour. We've been doing a grand tour of the solar system this entire year, and we've covered so many topics in previous streams. We did a live stream all about Mars and Jupiter and Saturn. They got their own live streams. I did a stream about the solar system infernos, Mercury and Venus, and we did a stream about the ice worlds, Uranus and Neptune. I've done other streams about other solar system bodies. I did a stream about comets, where we actually designed a comet here in my living room, which is very fun. I definitely encourage you to check that one out. We made a comet using ingredients you can find in the grocery store. And we did a stream on moons. I did my top 10 favorite moons. We did a whole stream about our moon, Earth's moon, of course. And we also did a stream about minor planets and dwarf planets. So we talked about all the other objects like asteroids and dwarf planets in our solar system. Although during that stream, I did leave out one dwarf planet, which is Pluto, the largest dwarf planet. So back then, I wanted to save Pluto for its own stream. And since we're going to continue these, we will be covering Pluto today. And before we dive in, let me just jump over to the comments because we have Gina saying hello from Rolla. Thanks for tuning in, Gina. Chris is watching from Davenport, Iowa. Thanks so much for tuning in, Chris. Sarah asks, is your bird going to make an appearance tonight? And she just might. We'll see how she's feeling. All right, now she's just eyeballing me. But if she is chilling out for most of the stream, then maybe towards the end I'll get her out and she'll join us, Sarah. But I'm glad you remember and wanted to say hi to Phoebe. Tammy, one of our longtime watchers, says, hi from Iowa. Thank you for still doing these. We have enjoyed these every week. Well, Tammy, I have enjoyed you tuning in every week and watching and commenting. It's such a joy knowing that some people have put this on their calendar for Monday nights and that we can be a part of your Mondays. And have been for some time. So Tammy, thank you for watching our streams. Barbara chiming in, saying hello from Savannah, Missouri. Thanks for watching, Barbara. Hi from Tyler as well. And Adeline is watching from Pleasanton, Kansas. So thank you all so much for tuning in and watching. So like I said, we are going to dive into our topic today, which is Pluto. And I want to start talking about Pluto. Let's start from the beginning, all the way back to its discovery and the search for it as well. Now, we've talked about the discovery of the planets. We talked about the discovery of Uranus and Neptune during our Uranus and Neptune live stream, which I should let you know was on December 12th, so you can check that out if you'd like. And let me get back over here. So now, after Neptune was discovered in the 1840s, well, Neptune was discovered based on analysis of perturbations in the orbit of Uranus. So Uranus was going around the sun, and it was kind of wobbling a little bit. And so scientists were like, that's weird. Something must be pulling on it. And that's why we discovered Neptune. But there were similar observations of motion in Neptune's orbit, and this led astronomers to speculate that there could be another body further out affecting Neptune's motion. Now, in 1906, a gentleman named Percival Lowell started an extensive search to try to find this ninth planet. And this search was conducted at the Lowell Observatory, his observatory in Flagstaff, Arizona. He called it Planet X at the time, and Lowell and his observatory conducted this search all the way up until his death in 1916. But to no avail, they couldn't find anything for those 10 years while they were looking. And due to legal troubles between Lowell's late wife and his estate, the search didn't resume until 1929. At this time, the observatory director gave the job of locating Planet X to a 23-year-old kid, I guess, a young adult named Clyde Tombaugh, who had just been hired by the observatory. And Tombaugh here, there he is. He's kind of famous, well, for a good reason, as you'll see, but famous around these parts because he grew up in Burdett, which is a tiny town in central Kansas with a population of less than 250 today. So Clyde here was a Kansas boy, and starting in his late teens, he began building several telescopes with lenses and mirrors designed himself. And then he did observations of planets, and he drew them, and he sent some of these sketches to the Lowell Observatory in Arizona, which ultimately hired him. They offered him a job. So Clyde joined on in 1929, and he was asked to systematically take photos of the night sky over consecutive nights and compare them to each other to see if anything was moving, to see if any dots, any of the stars he saw were actually moving, because they wouldn't be stars. And he searched for almost a year until February 18th of 1930, where he discovered a possible moving object on plates that he had actually taken the month prior in January of that year. So they had discovered the ninth planet at the time. Lowell Observatory, they had the right to name this object, so they received over 1,000 letters of suggestions from around the world, but ultimately the name Pluto was chosen, and the name Pluto was actually suggested by Venetia Burney, who was at the time an 11-year-old schoolgirl from Oxford, England. And to her, her proposal was that Pluto represented the Roman god of the underworld, which fit with the naming scheme of all the other planets. And also the first two letters of Pluto matched the observatory's founder and originator of the search, so it seemed like a fitting choice for multiple reasons. Kind of funny, upon a selection and announcement, Venetia she received a reward prize of £5 British, which is equivalent to about $450 today, so that's a pretty nice reward. Now, Clyde Tombaugh went on to earn a bachelor's and master's degree in astronomy from KU, another local institution, and he went on to discover hundreds of other asteroids, and he also notably continued direct visual observation, which was kind of rare towards the late 20th century. Most people were using computerized telescopes, but he was just using his eyeballs, and he did eventually pass away in 1997, although notably a small portion of his ashes were placed aboard the New Horizons spacecraft, which we will talk about a little bit later. We got a couple other people chiming in from the comments. Don't forget, this is live, so if you've just tuned in, we are taking a deep dive into Pluto, and if you have any questions or comments or want to give a shout out or let us know where you're watching from, be sure to comment there. Teresa says hi from Lenexa, and Stephanie says, all the best discoveries start with, that's weird. And that's definitely right, Stephanie. I like that philosophy. So, Pluto was discovered in 1930. But since then, we found a lot of other objects. So, and this is where the controversial part of our stream will be today, because I've touched on this a little bit, but we're going to take a bit of a deeper dive into it. What does it mean to be a planet, and how can you be defined as a planet? Well, Many other discoveries made in the vicinity of Pluto by the Hubble Space Telescope since Pluto's discovery have challenged the notion of Pluto's planethood, as well as the very definition of what it means to be a planet. Now, Pluto is so distant that even with Hubble, it appears as just a fuzzy blob, which we'll see some images of later. But Pluto wasn't alone, and when Hubble got up into space in the 90s and started really photographing deep space in the 2000s, it discovered a lot of other objects, a lot of other distant objects like an object named Quoar in 2002, Sedna in 2003, Haumea in 2003, and Makemake in 2005, all objects we visited during our Minor Planets live stream, which if you want to learn more about those minor planets, that was on November 9th, so be sure to check out that live stream. And then Eris was discovered in 2005, and Eris at the time was classified as a planet. At the time, it was measured to be bigger than Pluto, although now we know it's not quite as big as Pluto. But the fact that we found this object that was bigger than Pluto, it made scientists stop and think, okay, we maybe need to think about this definition a little bit. Because it got to the point where there are a lot of objects that could fit into this category. And Eris was kind of the catalyst there in 2005. So in 2006, a group of people named the International Astronomical Union all got together and they drafted up new requirements to be considered a planet. Their first draft had two requirements. Number one, you had to be large enough to maintain a hydrostatic equilibrium. So you have to have sufficient mass for your own gravity to overcome the rigid body forces that would keep you from assuming a round shape. So let's get another visual aid here. We're going to go over to Space Engine, which is a simulation of our universe. And we've got planet Earth here. And as you can see, Earth is round. It is nice and round, and any object large enough, generally thought to be at least 500 miles in diameter, or about 1 sextillion pounds, which is 1 followed by 21 zeros, is probably big enough for just gravity to kind of smush yourself into a ball. Anything smaller, like an asteroid, for example, would not be like that. So let me show you one of my favorite asteroids. I guess I'd say this is my favorite asteroid, Vesta. And Vesta is a great example of an object that does not have a hydrostatic equilibrium. It's very large, and it has many similar properties to planets, but it is not round, okay? It's not big enough for its mass to have smushed itself into a round shape. Now, the second requirement that the IAU drafted was that you have to be going around a star. A natural satellite like the Earth's moon, or another star orbiting a star could not be considered a planet. All right, that's pretty easy. Now, this first draft would have led to many other objects like Ceres and Eris, as well as Charon, one of Pluto's moons, being added to the list of previous 9 planets. Pluto and Charon would have been considered a double planet as well, which we'll see why. Actually, we'll see right now. Let's, if I can spell Pluto right, let's go over to Pluto here. So Pluto, which we'll see in greater detail later. I'm going to zoom out a little bit. Pluto is so small, and its moon, Charon, is so big that they actually orbit one another. So you can see here, Pluto has moves in a circle as Charon moves around it. And the center of this system is called a barycenter. And this is really the center of this Pluto-Charon system. And so they, like two dancers holding each other's arms, spinning around, Pluto and Charon pull on each other. And so this would be considered a double planet. There are also 12 other bodies that have been discovered at the time that were sort of in the queue, pending more data being gathered about their physical properties, and they could have been added to this list of planets. And then some scientists claimed that 53 other known bodies likely met the requirements, and that a full survey would likely reveal over 200 more planets. So this draft had a lot of problems. Now, it had some advantages. For example, it kept the limits natural instead of man-made, because we don't want to just say there can only be a certain number of planets, which seems kind of silly. And it also kept Pluto a planet. And as we know, Pluto has a place in many people's hearts. In fact, there was a rumor going around in 1999 of Pluto's declassification, and there was such a widespread uproar around the world that, the scientists definitely wanted a scientific definition of a planet, not an arbitrary one. But there were problems with this draft. Like I said, a lot of people felt it was too ambiguous. It would add way too many planets to the list. Also, icy bodies that are really far away, like bodies in the Kuiper Belt, which you can learn more about in our Minor Planet stream, they can likely support hydrostatic equilibrium at much lower masses. So these icy bodies don't have to be quite as big for their mass to form a sphere. Also, definitions can change over time. For example, Earth's moon, which you can learn more about if you watch our moon live stream, which was on November 30th of last year. Earth's moon is actually getting further away from the Earth every year, and there could be a point, it likely will be a point in the future, that Earth's moon is so far away from the Earth that the barycenter of the Earth-Moon system will be outside of the Earth. So the Earth will start orbiting its own moon, and then we'd have to change the definition. And there are even some double planet systems that could have highly eccentric orbits that could move the barycenter in and out. So basically, it'd be like a Schrodinger's planet of sorts. Sometimes the planet would be a planet, and sometimes it wouldn't be a planet, depending on where its moon is. Anyway, it just is very complicated. So after this proposal in 2006, there were a couple of amendments suggested. Some scientists wanted to add the requirement of lacking nuclear fusion, which was what stars do. Some wanted to add stipulations about size relative to other objects nearby. Some wanted to add arbitrary time limits, like saying only planets discovered before 1900 were considered a planet. But again, that's an arbitrary classification and not very scientific. Some proposed a new class of planet called a Pluton. But this made geologists very angry because apparently that word is used in the study of magma physics. And also this wouldn't have worked in other Romance languages like French and Spanish because Pluton is a form of the word Pluto, and it just would have been all sorts of confusing. Other scientists didn't want an object's orbital characteristics in the definition at all. They just wanted the object to define itself regardless of where it was. So anyway, there were many heated debates over the course of an entire week for hours and hours. All these astronomers in the International Astronomical Union got together and they were fighting and yelling at each other. But eventually they did come to a consensus. Let's get back over here. So here is actually a photograph of the vote. And a week after the first proposal, there was a final proposal, and it was voted on and ratified as official. And here is a photo of them voting on it. They used yellow cards to cast their vote. And this added a third requirement. And so this official proposal that was ratified in 2006 and it stands today has a third requirement. And the third requirement to be considered a planet, not only do you have to be big enough to be round, have to be going around the sun, but the third rule is that you have to have cleared your path of all other objects. You have to have cleared your neighborhood around your orbit. So basically you have to remove all the other bodies of comparable size. So the International Astronomical Union doesn't specify a certain number, but it's pretty clear to see this division. So if you look at all the official 8 planets, they are the only objects orbiting in their path, save for some very small asteroid-like objects. But Pluto actually shares its path with a lot of other large objects. In fact, it shares its orbit with a group of objects called Plutinos, which is a really cool band name. I already called dibs on that. Sorry, guys. Patrick and the Plutinos coming to you live in the next decade. So Pluto shares its orbit, and this is why Pluto breaks that rule. And there are some mathematicians who have proposed other official ways of deciding how to calculate if you've cleared your orbit, but this doesn't really change the definition. And this is what has been in place for years, now almost 2 decades. And you'll hear on the news of some crazy scientists who wanted to redefine the rules to make Pluto a planet, but it would take a lot of arguing and voting in the International Astronomical Union to make this happen. But let me know what you think. If you disagree with this choice, then be sure to post in the comments. Again, we all have a soft spot in our hearts for Pluto. Speaking of comments, let's jump over to the comments section. Hannah is watching and mentions the lovely koozie I have on my soda can here. Yes, that is soda, parents. Oh yes, Lloyd's Hot Sauce, a local hot sauce brand that I would definitely recommend. Very, very cool. Definitely not a shameless plug for some of my best friends. Megan is watching from Grand Island, Nebraska. Thanks for tuning in, Megan. So awesome. Patience says, good evening. Thanks for watching, Patience. And also says, haha, good band name. Yes, indeed. Aaron says, I thoroughly enjoy the Galactic Inclusive Pride Flag. Thanks for doing these. Absolutely, Aaron. And we do have a link to these if you want to download them for yourself. And we can post that link in the comment section if you'd like. Heather's also watching. Hey, Heather, so great to see you watching. Heather says, you make me want to learn more. Thank you for the dancing Pluto analogy. Absolutely, Heather. So great to hear from you. Amber says, or asks, is there a general miscellaneous category for the different exceptions to the planet determination and definition? Yes, there is, Amber, indeed. In fact, it's kind of complicated. There are actually a lot of different ways to categorize objects, and let me just show you real quick. I'm just pulling up one of my previous presentations. But here is just a sort of a flow chart showing all the different categories of objects to answer your question, Amber. And there is some crossover, just like how, you know, a rectangle or a square is a rectangle, but a rectangle is a square. There are some crossover objects here, but this is just kind of showing you generally how this all works out. And I'm not going to get too much into details on this because I did cover this during my Minor Planets live stream. If you want to learn more about that, that is our live stream on November 9th. And don't forget, you can rewatch all of our past streams on our YouTube channel. Just go search for Arvin Gottlieb Planetarium on YouTube. And by the way, if you're watching on Union Station's Facebook page, be sure at the end of the stream to go on over to the Union or to the Arvin Gottlieb Planetarium Facebook page and give us a like and subscribe, because we post all sorts of space-specific updates over there on our Facebook page. So you definitely don't want to miss any of those. So be sure to like and subscribe to the Planetarium's Facebook page as well. And subscribe to our YouTube channel too if you feel like it. That helps us a lot. If we get to 100 subscribers, I can finally give our channel a real URL, which is, you know, just extremely important in this day and age. But anyway, so again, thanks everyone for commenting. And if you are still watching and have any questions or comments, be sure to throw those in the comment section. All right, we're making pretty decent time here, and we are going to jump back over to our main discussion of Pluto. So now Pluto has a very long orbital period. So after we discovered it, we started learning about it, of course. It takes 248 years to go around the sun. In fact, I do have a kind of a sad fact about that. From the time that Pluto was discovered to the time it was declassified as a planet, it never got not got to celebrate a single birthday as a planet. So sad for Pluto, unfortunately. But again, Pluto's still out there, don't worry. So Pluto has a highly elliptical orbit, which occasionally crosses closer to the sun than the orbit of Neptune. So let's go back over to Space Engine here to see what I'm talking about. We talked about orbital characteristics during our live stream on rocket science, which was very fun. That was our longest live stream ever. On December 14th, we actually built rockets and launched them using a really fun program called Kerbal Space Program. So be sure to check that out if you want to learn more about that. But basically, to make a long story short, the eccentricity of an orbit is how oval-shaped it is. And you can see most orbits are very round, but some orbits are not. And I've got to turn my dwarf planet orbits on for us here. All right, so you should be able to see Pluto's orbit there. And you can see it's very wide, and it also is sort of angled. So I wish I could turn it off. Oh, you know what I can do? Let's go to the Pluto barycenter. There we go. Yeah, that's what I want. All right, so here is the center of the orbit of the Pluto-Charon system. And if I zoom out here, we can see and compare its orbit. So if I look from the top, you can see that it is eccentric, so it has a very oval shape. It's not as round. And also, you'll notice here, it occasionally gets closer to the sun than Neptune does. So actually from 1977 to 1979 to 1999, Pluto was officially the 8th planet from the sun. It was closer to the sun than Neptune was, which is kind of crazy. So, you know, Pluto did get to celebrate something kind of cool while it was still a planet. Pluto is the largest object of a group of icy bodies that have an orbital resonance. These are the Plutinos I mentioned earlier. Orbital resonance means that they orbit in a nice pattern compared to other objects. So basically, they have an orbital resonance with Neptune. So every 2 times Neptune goes around the sun, they go around the sun exactly 3 times. It's a nice ratio like that. And these Plutinos represent about 1/4 of the known objects in the Kuiper Belt. And if you want to learn more about the Kuiper Belt, be sure to check out that live stream I mentioned earlier. So some fun facts about Pluto. But Pluto was, for the longest time, still very far away and still very hard to image. In fact, here is up until 1994, this is what Pluto looked like, just a tiny blob of pixels. And even after the Hubble Space Telescope launched and its optics fixed, Pluto still looked like a very fuzzy blob. We really couldn't see much detail around it. So we really needed to explore it a lot more closely. And let's talk about that exploration. But first, we're going to check in the comment section. It looks like Eric's got a question. Is the IAU the only international astronomical group? If not, how did they get the job of defining what a planet is? That's a good question. And, you know, I honestly don't know a lot about sort of the geopolitics of the IAU and how that works. But, you know, like a lot of scientific organizations, they are just sort of a internationally agreed upon group of people. There are members in 82 countries, so essentially any scientist in one of those 82 countries is part of that. And it is a part of a larger organization called the International Science Council, which is another international non-governmental organization that unites various other scientific bodies. So I'm not aware of any other significant groups of these specific astronomy organizations. There might be small subgroups that deal with smaller issues like planetary science or rocket science, things like that. But in general, this is the most of the scientific community sees them as sort of a governing body. But that's a great question, Eric. Hannah commenting, saying that is the saddest Pluto fact I've ever heard. Not even one birthday. I know, it is very sad. But Pluto is still there, and Pluto got the spotlight very recently, and that is what we're going to cover next. So the imagery of Pluto was very limited, as we saw here. And here's a cool little animation showing how the images of Pluto have improved. And as you can see, we got some very nice close-up pictures of Pluto relatively recently. And that was with the New Horizons mission. Now, let's rewind a little bit and go through some background. Because in 1992, a Jet Propulsion Laboratory scientist jokingly called up Clyde Tombaugh, who's still alive at the time, and asked him if he minded if NASA visited his planet, quote unquote. To which Clyde, of course, replied yes, though he did comment that it would be a very long and chilly journey. Now, although this call was mostly in jest, it did eventually lead to a number of proposed Pluto missions. And then in 2001, unfortunately, 3 or 4 years after Clyde Tombaugh died, the New Horizons mission was officially selected for funding as part of the New Frontiers program, which is a NASA program that is aiming to explore the solar system in greater detail. Other New Frontiers program missions, by the way, include Juno, which we talked about the Juno mission in detail when we covered Jupiter all the way back, wow, in June of last year, June 29th. So check out our Jupiter stream to learn more about that. And then there's also the OSIRIS-REx mission. And then there's a fourth mission that was just approved. It's called Dragonfly. It was selected in 2019, and it's designed to be a robotic aircraft sent to Titan, Saturn's largest moon. If you want to learn more about Saturn, check out our July 6th live stream. But that mission is planned to launch in 2027, with a planned landing in 2036. So these missions take a long time. And as I said, the New Horizons program was officially approved for funding in 2001, and it took 5 years for the probe to be designed and launched. And it was launched in 2006. Now, this probe was the fastest probe ever launched. It had a 9.5-year flight to Pluto, and it was less than 3 meters in length, so pretty tiny. And for most of this journey, most of its electronics and non-essential systems were shut down to conserve power during its 3 billion mile trek. And to give you an idea of those cosmic scales, we've talked about this before, but there's kind of a nifty little trick you can think about cosmic scales with. Excuse me. Ooh. And so we measure distances in our solar system in astronomical units, which is the distance between the Earth and the Sun. So the distance between the Earth and the Sun is 1 AU, 1 astronomical unit. And then Mars is about 1.5 astronomical units, about 1.5 times the distance between the Earth and the Sun. The asteroid belt is about 2.5 times AUs, and then Jupiter is about 5 times. And then Saturn is 10 times, so it's twice as far as Jupiter. Then Uranus is about 20 times, twice as far as Saturn. And then Neptune is 30 times, and Pluto is around 40 astronomical units. So 40 times as far away from the sun as Earth is. And let's take a look at the New Horizons mission. Now I want to bring up this cool program. This is called NASA's EYES, and it's a free program you can download for your computer, and it has a bunch of really awesome 3D visualizations of the solar system and missions. And it actually has an entire module all about Pluto. So we're going to load it up here, and we are going to take a little look at the New Horizons mission. So this mission was launched in 2006, as I mentioned, and it didn't arrive at the Pluto system until July of 2015. And on July 14th, 2015, we finally got our closest look ever at the most distant world ever visited. So this is going to give us a nice tour. Now this is New Horizons' current location, but I want to do a replay. So we're going to rewind time back here, and we're actually traveling pretty quickly. We're a day before New Horizons flyby, and we can see the spacecraft here. Now while we are traveling, actually I'm going to pause here, and we're going to take a look at this spacecraft, just get a little tour around it. It's pretty tiny. It's a nice big satellite dish and dozens of imaging sensors all over it. And then this is its power source in the back. And it has a number of different instruments that it is capturing imagery of Pluto. Let's just go ahead and play this here. And we can see these different instruments up here, and it'll tell us about them. But basically, these four main instruments were LORI, the Long-Range Reconnaissance Imager, which got telescopic observations of Pluto and its moons. There's RALPH, which is a visible and infrared imager and spectrometer, provided color and heat maps of the Pluto system. There's ALICE, which is an ultraviolet spectrometer, which analyzed composition and structure of Pluto's atmosphere. And then there's REX, which stands for Radio Science Experiment, which measures atmospheric composition and temperatures in the Pluto system. This is really awesome. You know, we can adjust the time scale here, but we're going to let this play out. Now, as New Horizons was flying towards Pluto, it was traveling at 52,000 miles per hour. You can see it's thrusting and moving around and changing its position so we can take different images of the Pluto system. But it was traveling so fast that its close encounter with the dwarf planet lasted mere hours before it whizzed by the Pluto system. As we found out during this flyby, the Pluto system was far from a frigid, featureless world like we used to think it was. It turns out that the Pluto system, and Pluto specifically, has all the characteristics of a dynamic living planet. Yes, it's very cold on the surface, minus 380 degrees Fahrenheit, which is cold enough to freeze nitrogen solid. But there's a lot of really awesome things on Pluto's surface, which we'll look at here. So I'm just going to fast forward, just so you can get an idea of the scale and speed here. So if we get close to Pluto here and we go down to real time, we'll actually still be able to see the New Horizons spacecraft flying by in real time. So here is real time imagery. So you could actually sit here and watch the Pluto flyby in real time, and you can see its sensors and also the pictures taken by the spacecraft, which is just I love that NASA provides all this stuff for free. It's crazy. You just download this, and it's this really fun interactive program that lets you, you know, do sort of a ride along with one of these awesome missions. So here you can see its relative speed here to Earth, I believe, and counting down to its closest approach. So it's traveling so quickly you can actually see, just barely make out Pluto moving by here. So if you were on the spacecraft, you would be able to witness this in real time. Let's let that kind of drive for just a minute before we start talking about Pluto. Check in the comment section. Don't forget, this is live, so if you have any questions or comments, be sure to chime in. Let us know where you're watching from. Patience says a rocket science app was awesome. I'm assuming you're talking about the Kerbal Space program we used a few weeks ago to do our live stream about rocket science. That's so awesome, Patience. Glad you checked that one out. Rachel says, checking a little late this evening, but watching from Leavenworth. No worries, Rachel. Thanks for watching. As a reminder, if you want to rewatch the beginning of the stream, you'll find it on our on our Facebook page, of course, but also our YouTube channel. So be sure to subscribe over there as well. Aaron is hanging out and watching from Wichita. Thanks for tuning in, Aaron. And Eric asks, do the satellites have any propulsion other than inertia from launch? And they absolutely do, Eric. That's a really great question. This particular probe here has a number of propulsive systems, and usually they are inert gas. that just sort of expels, sort of like a little blow dryer going, just pushing out. And they use that inert gas because they don't want the gas to mess with the sensors or anything like that. And so the spacecraft are able to bring some propulsion on them, but also they have gyroscopes in them which are able to change their orientation. So that's what they primarily use, because that just uses electricity, which is more renewable. You know, these spacecraft often have solar panels or other electricity generating systems. And I'm glad you brought that up, Eric, because we do talk a lot about propulsion systems and different systems for moving spacecraft during our spacecraft or Spaceflight 101 live stream. And that was, again, 3 weeks ago on December 14th. So check that one out. It is one of our longest streams, but it is a fun one. I exploded a spacecraft on the launch pad on purpose, but we also landed one on the moon, which was very fun. We've got Andrew tuning in. Thanks for watching, Andrew. So great to hear from you. Andrew says, hi, Patrick, watching from London. That's awesome. Oh, what time is it in London? Oh my gosh. Does it take long to transmit that kind of imaging data back to Earth, given the distance? That's a really great question, Andrew. And it absolutely does. And to find out, you can use some pretty interesting tools. Let's see one of them now. Let's go to Wolfram Alpha, which is a really fun sort of free calculator website. And basically, to find out how long it takes a signal to reach any spacecraft, you can ask this program, and it's a computational search engine. Now, signals to and from spacecrafts travel at the speed of light. Often they are transmitted in radio waves, which is a type of light, electromagnetic radiation. And so we can ask how many light seconds away is New Horizons? And hopefully it will tell us. I'm doing this live. I'm pretty sure it works. Let's see. No, let's just search for New Horizons. I believe it has spacecraft data. All right, yeah, there we go. So maybe I do that. How far away is New Horizons spacecraft? All right. So it is 4.6 billion miles, but we can ask it to calculate that in light seconds. And so it should tell us how long it takes light to reach this spacecraft. So it takes about 25,000 light seconds, but let's do light minutes. That might give us a better time scale. And of course, New Horizons is farther away now, but this will give us sort of a general idea. Wow, 417 light minutes, and because I don't want to do basic arithmetic in my head, let's ask in light hours. Okay, so right now, it takes about 7 hours for a signal from Earth to get to New Horizons, and that's why it's so important for us to plan all these maneuvers very far in advance, and they certainly do that. But Andrew, that's a great question. Thanks for bringing that up. And that definitely factors into space exploration, because the farther away we get, the harder it is to control spacecraft, and we can't really do it live. You know, Mars, for example, is around 20 light minutes away. So we can't drive the Curiosity rover around with a remote control, basically. We have to program it in advance and make all these calculations because if an error happens, then we can't change it in real time. We just sort of find out if we crashed into a Mars rock 20 minutes later. But that's a great question, Andrew. And thanks again for tuning in. So great to hear from you. All right, so we were talking about the New Horizons spacecraft, and it flew by Pluto here, and we'll just fast forward and we'll see this whole flyby with our NASA eyes. And now again, so it's flying so fast, and it didn't have enough fuel in it to slow down and put itself into orbit around the Pluto system. So unfortunately, it passed right by Pluto. But while it was passing by Pluto, it got some really great imagery, and we can see that imagery with Space Engine here. And we've used the Space Engine program before. This is a paid program, unfortunately, but it has some pretty incredible imagery. And I've actually adjusted the clock here to be right around when New Horizons flew by Pluto. So this is exactly what New Horizons saw. And this program, of course, has the newest imagery of the Pluto system. We can see it here. Now Pluto, and let me rotate it a little bit and give it more of a familiar orientation here. There it is. So this world, first of all, with these close-up images, we did see that Pluto was round, so it did qualify as a planet on that characteristic. But again, it unfortunately has not cleared its orbit of other objects. It shares its orbit with those Plutinos. But we got a lot of really great imagery. Now, we only got pictures of one side of Pluto, of course, since it was traveling so quickly. But we have mapped out that side, and we have named a bunch of these regions. Many of the southern regions of Pluto are actually named after famous monsters from fiction and mythology. There's the Cthulhu region from Lovecraftian tales. There's Krun Macula, which is an ancient Iraqi lord of the underworld. There's Ala Macula, which is a Nigerian goddess of death. The Balrog Macula, named after the Lord of the Rings monster. Pandemonium Dorsa, named after the capital city of the underworld in Milton's Paradise Lost. So a lot of really underworldly names, which is pretty fun. And then there is the most famous region probably, which is the Tombau Regio, named after Pluto's discoverer. More popularly, though, it's named as Pluto, or it's named after Pluto, or it's named as Pluto's heart. And so the images of Pluto taken by New Horizons showed sort of a distinct heart pattern here, and that's often referenced, and we use that in the title of this live stream, of course, From Pluto with Love, with that famous image. And so this gives people a lot of warm and fuzzies about Pluto, as it should. Now, the western lobe of this heart, this region here, is named the Sputnik Planitia, which is a giant plain of frozen nitrogen, methane, and carbon monoxide that stretches for 1 million square miles. And at its edge lies a mountain range of pure frozen water ice that rises 3 miles above the plain. But there's something else strange about this region. It has no craters. Now, you'll notice here, the surface of Pluto is covered in countless craters similar to Earth's moon. These craters on the moon and on Pluto are caused by countless impacts over the course of the solar system's history, and because both Pluto and the moon don't have active geology or meteorology, weathering and erosion cannot remove those craters, and so they stay for an eternity. But that's why it's weird that this region has no craters, very weirdly enough. So as New Horizons passed by and as we analyzed its data more and more closely, we got some really amazing close-up images of this region, which we will attempt to fly in here to see. So let's just fly in right here near the mountains. This looks like a decent spot, and I'm going to make it a little bit dimmer so you can see this a little bit more clearly, but there are some pattern regions right over here. So these shapes here, which kind of look like a network of hexagon and pentagon shapes that crisscross this nitrogen surface, are very interesting, and they reminded scientists of other features of similar patterns found in nature. For example, the surface of the sun exhibits a similar pattern to this, and also the surface of liquid that's being heated from below has this pattern. Now, we call this pattern convection, or what creates this pattern is something called convection currents, where a material is heated, the heat rises through the fluid, and then it's cooled and falls back down, and then is heated again. And these currents form these distinct patterns, these patterns that we saw on Pluto here. So basically, what this tells scientists is that there is likely a heat source deep inside Pluto. So somewhere deep in Pluto's mass, there may be radioactive material that's releasing energy to heat this otherwise frigid world that's so far away from the sun. Some scientists believe there could even be an ocean of warm water below the surface of this region. Perhaps Pluto's heart is the site of an impact that punched into this deep hole and released some of that fluid, exposing that deep ocean and causing this region. Now, like I said, because New Horizons was traveling so quickly, it didn't have enough fuel to slow it down for a stable orbit. And we only got to see really one side of Pluto, although we did get imagery of Pluto's other side, because Pluto, one day on Pluto is about 6 Earth days long. So as New Horizons was approaching and leaving, it managed to get pictures of the other side of Pluto, albeit at a lower resolution. In fact, here in Space Engine, we can see that by simply fast forwarding time here. And so the other side of Pluto, you can see we have some images of it, but with not quite as much detail. So there are still many mysteries hiding in this icy world. Now, we are almost up with our stream. There's one more surprise to talk about with Pluto, but we're going to check into the comments, and this is your last chance to ask any questions or make any comments. So if you're still watching live, be sure to chime in the comments for us, because we are going to be ending our stream relatively soon. Jim says, I love the names. I think referencing the names of Pluto's surface, very creative. You know, when we find so many things in our solar system, we start running out of ideas, and I think it's kind of cool that we look to fiction for some of those. Rachel says, also laughing at the freaking amazing names. Jim asks, or says, when I was a kid, I used to lay on the grass and contemplate the stars. I felt so small. Does the planetarium do live night sky presentations of the Kansas City sky? I'm so glad you asked that, Jim. And the answer is yes, of course we do indeed. When the planetarium is open, which we will reopen to the public on the 14th of January this year, we have a daily live star tour. And this is a traditional planetarium show narrated by yours truly, or one of our other amazing planetarium educators, where we take a tour of the Kansas City night sky and I show you different stars and constellations you can see, the mythological stories that go along with them, as well as other deep space objects like galaxies and nebula, and maybe even a planet or two if you're lucky. So Jim, I'm so glad you asked, because we do indeed do star tours, in addition to our other amazing documentary programs and kids shows for our early learners. So I definitely encourage you to come to the planetarium and see one of our live shows if you'd like. Of course, buying a ticket is a great way to support the planetarium, which is part of Union Station, a nonprofit organization, so every little bit helps. Patience says, subscribing now on YouTube. Thanks so much, Patience. That's so awesome. Remember, all of our live streams are posted to our YouTube channel. Be sure to give us a like and subscribe over there so you don't miss any of that cool content as well. Mandy says, what is next for New Horizons since it passed Pluto? That's a great question. And there is a lot. So we've talked about some of the other stops that New Horizons made at some of the further objects beyond Pluto. And if you want to learn a little bit more about some of those objects, then be sure to check out our stream about minor planets, which we did on November 9th. But there are some missions to some mission extensions that have been proposed for the New Horizons team to look at other Kuiper Belt objects far beyond the orbit of Pluto. And to search for new objects, just to try to find them and add them to the list of other places to explore. It is on a, it did encounter an object called Arrokheth, which is pretty cool. I wonder if Arrokheth, if its imagery is available in Space Engine. Let's see here. Well, this asteroid appears to be invisible. Oh, I think I've turned it off. Hang on. There we go. Oh gosh, we do not want the orbital markers. All right. Yeah, there we go. Okay, so, oh no, it's still disappeared. No, why isn't it there? Spacecraft, installations. Huh, okay, well, this asteroid, oh, maybe it's because it's a dwarf planet, dwarf moon. All right, well, I'm not sure why that object is invisible, but it should be right there. Anyway, the New Horizons spacecraft encountered an object called Arrokheth, which we can see here. Let me pop this out for us. All right, there is a picture of that object. A really interesting object that sort of has these two masses that are kind of globbed onto one another. So that was a notable stop post-Pluto on New Horizons mission. But there are other post-Pluto events that have been proposed to look at other Kuiper Belt objects. Yeah, no, so nothing specific as far as I can see here. Yeah, we still continue to contact the New Horizons spacecraft, and will continue for many years to come. We still talk to the Voyager spacecraft, which were sent in the 70s. So that's a great question. Mandy, thanks for asking that. Anne says, watching from downtown Kansas City. Thanks for another interesting lecture, Patrick. Well, thanks for watching, Anne. Appreciate your support. Patience says, is there an equation to determine the north side of Pluto? Ooh, that's an interesting question. We determine sort of the orientation of planets really based on their magnetic field, similar to how the Earth's magnetic field defines what the North and South Pole is. So we don't really need an equation. The New Horizons spacecraft took magnetic readings as it passed Pluto, I'm sure. That sort of led us to orient Pluto in that way. But that's a great question, Patience, for sure. All right, so I mentioned that Pluto had one more surprise, and this will be the end. This will wrap up our stream today. So let's go back to Pluto here. And as New Horizons passed Pluto, it turned its camera back on Pluto, and there it's showing us already. And it discovered that Pluto has an atmosphere. So Pluto, in addition to likely having activity below its surface, is also active outside of its surface. It has an atmosphere. Now this atmosphere is 1 million times thinner than Earth's, but interestingly it extends out past further than Earth's atmosphere, which you can see in this diagram here. So Pluto's atmosphere is actually technically bigger than Earth's, which is kind of crazy. But pretty amazing that we are able to see this atmosphere. And another interesting thing is that the presence of methane in Pluto's atmosphere actually creates a temperature inversion, kind of like a reverse greenhouse effect. So the atmosphere of Pluto is actually warmer than the surface of Pluto by a few dozen degrees, which is kind of an interesting feature there. But pretty cool that as New Horizons passed Pluto, it revealed one more mystery there, that a thin blue sky hung over that potential ocean of hidden water below the surface of Pluto, 3 billion miles away from Earth. So who knows? You know, hopefully we'll go back to Pluto someday. We'll explore more below the Sputnik Planitia there, perhaps finding convection currents with liquid, and perhaps something even more we could discover far away on this icy world. But in the meantime, we will continue exploring the worlds that we are exploring. The Juno mission is the other exciting mission happening right now. And again, that's all about Jupiter. So if you want to learn more about Jupiter, check out our Jupiter stream way back in June 29th. But for now, this will conclude our little live stream deep dive into Pluto, the final stop on our solar system tour. We've covered just about everything in our solar system, and we have so much more exciting topics waiting for you. I've mapped out a bunch of interesting topics just to give you a little tease for some upcoming topics. We're going to be bringing back some of our fan favorite topics. We will take another deep dive into Hollywood pretty soon, where we'll look at a bunch of other movies that we didn't cover during our previous Hollywood live stream, which was quite a while ago, all the way back in July 20th of last year. But we'll do a redux, a sort of an electric boogaloo, if you will, revisiting Hollywood astronomy and all the science and space stuff in the movies. We are going to do a stream, more streams about mythology. We'll take a look at Western astronomy as well as ancient British astronomy, Celtic astronomy, mythology, things like that. We're going to take a look at space technology in the future. And, you know, I did say we covered pretty much everything in our solar system, but I seem to think that there's one planet that I haven't talked about yet. If you think about what planet that is that I missed out on, then let me know in the comments, because I think I've covered everything. I don't know if there's anything else that I might have missed. So let me know if I seem to have missed any planet during our streams. But if there is, we'll definitely cover that one. But a lot of exciting things coming up. A little programming note, but we are going to switch things up a little bit because the planetarium is closed to the public this week. We're doing training and maintenance. So we're going to bring back our Fan Fridays stream. So way back in the early days of last year, back in April and May, we did Fan Friday streams where every Friday we invited guests to jump on the stream and ask questions and comment, and it was just sort of a more interactive thing. So I'm planning on doing my Fan Friday live stream this coming Friday. So this Friday, at Friday the 8th of January, we're going to do a live stream that's all about you guys. We are going to be answering your questions live, so be sure to think of all those questions and come watch that stream. That should be a fun one. Switch it up a little bit. So we will be taking a look at all of your questions. We'll also do some highlights over the coming year. So I'll do some highlights of celestial events coming in 2021. So be sure to check that out. Oh, I also promised that Phoebe would make an appearance. So let's see if she will join us. Come here. Come on. There we go. He was very well behaved during the stream. Say hi to everybody, Phoebe. But we are wrapping up here. I have been your Planetarium Specialist, Patrick Hess. Thanks for watching another live stream. We will see you on Friday for our Fan Friday live stream. And then after that, we will join back in with our Monday live streams with a bunch of fun topics planned for the next few months. So thank you so much for watching, everybody. Let's see if we've got any last second comments. So Sonia says, very interesting. Thank you. Thanks for watching, Sonia. Tasha watching as well. Oh, so great to hear from you, Tasha. Thanks for watching. Hope you enjoyed the stream. Rachel says, thank you, Patrick. Looking forward to future streams. Looking forward to you joining us, Rachel. And Eric says, is it the planet Earth? I think you might be right, Eric. Earth is the only planet I haven't talked about, and I have plans to do a live stream all about Earth, which may be my least favorite planet, but it is a pretty cool planet. So what do you think, Phoebe? I think Phoebe thinks that's a great idea. So I hope you guys have a wonderful start to your year. We will see you back here on Friday for our Fan Friday live stream. And have a great night, folks. Bye-bye. Say bye.